Hi everyone. I am here with one interesting coding problem on arrays. This is move all zeros to end in array in place. Okay. So for example, if the input is given as 0, 2, 7, 0, 8, 0, 10, the output is to be produced as 2, 7, 8, 10, 0, 0, 0. That means we are moving or we are shifting the zeros to the end of the array. And what is that they are expecting? It is to be done in place. The meaning of in place is the result is to be stored in the original array A and no extra memory is to be used. So that is the meaning of in place. So for this one, most of the people, they will, those who are working with Python, they will follow this approach, like they will separate non-zero elements and zeros, and then they will concatenate those two lists and to store the result back in array, the given array A. So with the help of this list slicing, they will copy the result into A. So finally, if you print A, the result will be appearing in A only. Okay. So according to this direct approach, what is that we are doing? We are considering one array A which contains non-zero and zero elements. Then with the help of list comprehension, I am creating one list non-zeros NZ and I am considering all the non-zero elements from A. And in the list Z, I am considering all the elements that are equal to 0. Okay. Then concatenate NZ and Z. So what will happen? These two lists will be concatenated and we are storing the result in the original array A. Now what will happen? The original content of A will be replaced with this new one. Okay. So this is one way to copy one array into another one using slicing operator. Okay. So finally the result will be printed in A. Then, so this works well, but what is the problem with this approach? The problem with this approach is we are consuming additional memory here. So we are using two lists NZ and Z. Okay. So these two are like extra memory consumed by the program. This should not be allowed. Okay. So what they are expecting, without using extra memory, do this process. Finally, the result should be available in A itself. Okay. That is the expectation from this problem. But we are consuming extra memory NZ and Z. Okay. So to overcome this, we can go for alternative approach, two-pointer technique. Two-pointer technique. So two-pointer technique considers two pointers. For example, say IJ. IJ. Some people call it like left, right. Some people call it like start, end. Okay. Here I am naming two pointers as I and J. So for some problems, depending on the nature of the problem, I starts at 0 and J starts at n minus 1, where n is the length of the array. Okay. For some problems, I will start at 0 and J will start at I plus 1, that is 1. Okay. So depending on the nature of the problem, we will set initial values to I and J like this, or we will set with 0, 1. Okay, so in this case, we need not begin with the left side or right side. So our approach is to start from the beginning. I mean, start from 0 and J will be assigned to 1. Okay, then here I have devised 4 rules. 4 rules. So according to these 4 rules, the first one, if AI is 0, AJ not 0. This is rule 1. If AI is 0 and AJ not equal to 0, what is to be done? 0 is to be shifted to the end, right? So here perform swapping. Perform swapping and increment I and J operators by 1. I mean I and J pointers by 1. Got it? This is rule number 1. Then rule 2, is a of I not equal to 0, a of j is also not equal to 0. In this case, what is to be done? Nothing need to be done. Just proceed with incrementing I by 1, j by 1. Okay. Then, rule 3. If a of I not equal to 0, a of j equal to 0. So this is expected thing. Why? Because non-zero element is appearing first and zero element is appearing next. Okay, no problem for this also. Here also just increment I value by 1, j value by 1. Okay. Next, last case. The fourth case is both are zeros. A of I is 0, A of j is 0. In this case, what is to be done? So just increment j by 1. Keep I there itself. Keep I there itself and go and check if any non-zero element is found. So that's why only j will be incremented by 1. Okay. Then if any non-zero element is found at jth position, then swapping can be done. And all these rules or all these steps are to be applied while j is less than length of array. Got it? Okay. So these are the 4 rules I consider. This makes my job easier, and with the help of this 2-pointer technique, we will easily carry out this operation. And what is the advantage of this approach? We are not consuming any extra memory except for this I and j. We are not taking any additional temporary lists or something. And finally, the result will be there in A alone. Okay. So this is the advantage of this method. Now let us look at the code. A is the given array, I is set to 0 and j is set to 1. Then while j less than len of a, the first rule, a of j is 0, a of j not equal to 0, swap them and increment I by 1, j by 1. Second rule, a of I not equal to 0, a of both are non-zeros. Nothing need to be done, increment I and j. Next, one is non-zero, the second one is 0. In this case also nothing need to be done, increment I and j. Then when last case, fourth case, a of I is 0 and a of j equal to 0, that means both are zeros. You wait, you hold there with I and increment j value until you find non-zero element. Okay, so this is the set of rules I have designed using 2-pointer technique, and finally the result will be available in A and we can print the result. Okay, so I hope you understood this logic. So if you would like to focus more, just pause the video and hold the screen and then observe this one, observe these rules. So this same technique can be applied to several such problems and we will discuss them in due course. Okay, so now let us quickly run this code. I have already typed the code in Colab. Let us quickly run the code and see whether we get the correct output or not. This is direct approach. So we got the result correct. But what is the problem with this? Space complexity is high. The time complexity of this direct approach is big O of n only. Okay. What is the time complexity? Big O of n only. But the space complexity is also big O of n. Here, in this 2-pointer technique, the time complexity is big O of n, but the space is reduced. Okay, so as they have asked in place, this 2-pointer technique is very much suitable for that. So initially we are taking the array, then I is set to 0, j equal to 1. This explanation I have given already. Let me run this. Yes, we are getting the output as per the expectation. I hope you understood the content. If you understood the content, hit like button, share it with your friends and subscribe. Thank you.